Hello, welcome to Crystal Core Skills. This video is about different types of lines. So we are going to have a look at different types of lines that we may come up with in geometry. I may not be able to cover all type of lines, but I will try as much as possible to come up with as many types of lines as possible. So let us get started. So lines, line types. So the first type of the line that you can think of, I would say family is called bisector lines, and which includes one of the bisector is angle bisector. So angle bisector is something like this. You have like points like that, and that angle, let's say A, B, C, and that is a bisector for the angle. Let's say this is point D, so that angle ABC is equal to angle ABD is equal to angle DBC. So the second type of bisector is perpendicular bisector, which is just you can use like a line segment. Let's say line segment AB, and then we have another line segment there, which is actually, let's say, ABC, D, and perhaps we can have a point there, D, so that this line, I would say, let's say this line segment intersect at point C at a right angle, and the best way to measure this is to come up with some sort of a circle, so that the area under the first quadrant will be equivalent to area under each of these quadrants, so that you can have right angles all through the circle. So perpendicular bisector actually divides a circle into equivalent sectors, like four different types, or parts of the circle will be equal in terms of areas. And then we have segment bisector. Segment bisector line, you can think of any line segment like this with the point AB on it, and the segment could be bisected by either a line or a ray. For example, we can have another line there at this point, and a point will be there. So at point C, the distance between AC and B and C, B are equal. If that is true, then this line segment bisects another line segment at point C. You can have another bisector like that, which is a segment bisector. Could be a ray with one point at C, and maybe you can put another point like this, so this ray is just passing like that, dividing this AB into equal parts. So point C will always be a point of intersection of the line. So that's basically bisector lines. And then another family of lines that we may experience is the symmetry lines that divides object into two equal parts, or it divides an object into half, such that when you put them together you form an overall object. Or it could be a line to do some kind of like make an image of the object, if you like. For example, we have reflection lines in symmetries like this. You can have a line like that with points AB, and then you may have an object here. For example, I am standing here, so when I'm looking at that point, when I hit this line, I get a reflection of me on the other side. So this is a reflection line. An example of this could be like a mirror. So when you look at yourself in a mirror, consider the mirror to be like a point of reflection, then you will come with something like that. Another type of line that can come under symmetry is the line of transformation line. Transformation line. This is a line that you can use to relocate the object in different orientation. For example, I am sitting here right now. Now, if you want to transform it in a different location with different orientation, you use this kind of line called transformation line. You can draw it like this, and can make it be like a segment of because it's going in one direction, not in both directions. It is a good idea to use a ray to present this kind of transformation. Let's say you want to turn me on the side way. It could be that way or that way. So if you're turning me that way, that means I am going to be transformed like that way. So I will be like here, lying, my head will be facing there. Or you're going to transform it this way, then I will be like on this side here, and my head will be facing that way. Or if you want me to stand with my head, you can just draw that arrow there. Then I will be with my head down. Help me, yeah. So that's transformation line. And another line that you may have under reflection is under symmetry, could be the result of that transformation. It could be like a straight kind of line, and this line can be used to change the position of the object via rotation at a given point. For example, we want to rotate about this point A. Now, let's say the object is standing here. I'm still standing here. So by rotating this line, you're going to change my position because this line is defining my location. Now, when you try, let's say we rotate it at that angle, so this line will become, let's say point B will be there, and then I will, instead of being here, I will be somewhere like there. If you rotate it to 180, that means I will be flat out on that side, so I will be lying like there. So if you rotate to 360, you will bring me back to my location. So that is a rotation. So rotation, yeah, so this line can be classified as line of rotation, yeah. Now, another type of line that you can come up with is a perpendicular line. So perpendicular lines are something like this. Let's say A, B, C, D. So that when you have one line like this, another line like that, they intersect at a right angle. And perpendicular line is not equal to perpendicular bisector, because when you take the reverse of this line here, you will get exactly that line. So each line is the reverse of the other, and that gives you what is known as perpendicular line, which intersect at the right angle. Another line that you can have a look at are parallel lines. So parallel lines are two lines, let's say A, B, and another line with C, D. Are two lines which do not intersect, so they're parallel to one another. They keep on going like that without touching one another. They could be having equal length or not, but as long as they have no chance or no possibility for intersecting, then you can call them parallel lines. So you can either leave them like that with that equal sign, or just say AB line segment AB is parallel to line segment CD. Sorry, I'm not using a lot of naming here because we are going to look at the naming convention. I mean the naming convention in a different video that will allow us to go through all different kind of lines and how to name them, and naming the points as well. So just bear with me, just get the definition as they are at the moment, and let's go to the next type of the line. Another type of line that you may experience apart from perpendicular parallel lines, and this rotation, transformation, and reflection, including the bisectors, is you can come up with a line called the grid lines. The grid lines actually help us in reading the map system, and they're very, very important. I'm going to produce one video just to emphasize on the importance of the grid lines as well as the coordinate lines. But this one helps us to locate the place. For example, you can have grid like 1, 2, 3. 1, 2, 3. So grid line locate a space or some specific position within a space, and the grid will help us to locate that position. And this kind of line is used in the GPS system, used in the map system, used in a global, I would say in the direction system, if you like, so that when you are given a position like in a map system, like you're given that position location there, you can just go like 1 step, 2 step, 3 step, and then 1 step up, so that you can just find this line. I think the drawing is quite strange, but you need 2 steps to get here. So you go like 1 step, 2 step, 3 step, and then 1 step, then somehow between the second step you find the location of the position there. So that is a grid line, which is similar to the coordinate lines. Coordinate lines, they are almost like grid lines, but with coordinate lines you need some arbitrary point to start from. For example, you can have the lines like let's say this is y-axis and this is x-axis, and you have that arbitrary point 0. This is where you begin from. So from 0 you go to 1, 2, 3, 1, 2, 3, and so on. And this one -1, obviously, -2, -3, and so on. And then 1, 2, 3, and -1, -2, -3, and so on. So that you can use this position to locate, to describe the position as well as location. For example, they may say get the point or position at let's say 2, 3. So you start with the horizontal axis. You just go and count 1, 2, and then you go up to along the vertical axis like 3 steps. So 1, 2, 3. So you will find that location there from the point of origin. So that is a coordinate system, and it helps us not only to locate the place but also to describe how to get there. So grid line is very useful, and coordinate system very useful. You can have 3D coordinate system, like you can have like y, x, z there, so that you can find a given location there. This is mainly used in the theory of relativity and the globe system. It's very handy when you're looking at different kind of lines like in the globe. And that is another theory that we're going to look at, and that brings us to another type of line, which is called the altitude. The altitude lines is a line that can help us to I would say it could be a line, it could be a ray, but I think the best way to present it is to use a ray with 2 points. It helps us to locate how high or how far the object can go high, up like that. So we have this ray to indicate the latitude, the altitude of the object, how high the object can be. Let's say the base is A, B, and the ray is from C maybe to D. So it's the measurement of the height. So this line helps us to measure the height of the object. Apart from altitude, we have what is called latitude, and longitude. I have decided to put these two together because you cannot do with one without the other, just like X and Y coordinate system. But these are the lines that help us to locate the place. It's another way of saying X and Y, but latitude and altitude are mainly used in the mapping system as well, like in the pilot system to locate the position on the space, and even to maybe guide and direct the pilots when they are piloting the plane to go from one country to another. Just like in the globe, we have the longitude and latitude have major lines. For example, everything begins from the circle, and this circle we have like 90 degree there inside, and this line here that we are seeing will be like our when you're talking about the globe, it will be like this will be like the latitude, and then from this circle you can come up with all sort of circular kind of line, and this circular line is actually forming what is called equator, which is equator. So the major axis of this line, the latitude and longitude. For the longitude you call it equator. For the latitude it's called prime meridian. So they are used in the mapping system. For example, at the point where equator meet the prime meridian, we know that is 0 somewhere in Africa. There. So we know that South America could be there, North America could be there, Europe could be somewhere there, and Asia could be somewhere there. So you can have different meridians, but the prime one is there. And the equator also, you can have many parallels. You see this one, the minor one, you call them parallels, and they're measured in degree. Obviously this is 90, so from 0 degree you can measure 10 degree. 10 degree can have like let's say 20 degree. Let's measure in 30 scale, like 30 degree, 60 degree, 90 degree, 120 degree, and so on until when the globe meets on the other side. So that, for example, if you want to go to let's say this one is 10 degree as well, let's say 30 degree, 60 degree, let's say 80, let's say 90, 60, and 30, 20. So the scale is not chosen well, but that's the basic idea. The same thing, 10 degree going round, and the circle is there to actually guide us. So from here, if you want to go from, let's say, from Africa to somewhere in America, in South America, North America, you follow this great line. Maybe you need to go like let's say you are coming from this point, you need to go 10 degree to the east of to the east longitude. Then you go another 30 degree to the north latitude, and then you come like you measure from 1, 2, almost 70 degree to the west, to the west of west longitude. So you're going latitude north, then longitude west, and then you come with your plane here. The good thing with this is like each and every grid may be used as the motorway on the space for the plane to fly from one location to another. That's why it's very rare to see plane colliding on the space, because geometry helps us to kind of like design the highway system for the plane, for the highway system in the space for the plane to follow. So that's roughly the basic idea of longitude and latitude. And they are all line system and they form some sort of coordinate system. And that's how geometry provide us with a tool to solve practical and critical complex problem in the space for directing the plane in the space. That's just a few examples, and I hope this video has been informative, and thank you for viewing. Next, we are going to have a look at how to give names to these points and lines and angles, and then see different kind of angles that may come as a result of this point, as well as the shape. I see you next, and I hope this has been informative. Thank you for viewing.